Good to go?
Good to go.
All right. So, evening everyone. If you're watching from the future, it's July 1st, 2026. That might be relevant because some of this stuff moves a little quick. And tonight we're going to be talking about the magic of the third dimension, a little bit of a primer on 3D printing. Now, I know some of you have some experience in this already, but hopefully even those of you who have printed once or twice will learn something cool tonight. All right, let's see, is this going to work? Maybe not, maybe. Is it in my machine? All right, well, I'm just going to do that. All right.
Let me see for a second.
Yeah, go for it. Was it? Okay.
Yeah.
It was off.
It was off.
Okay, so I apparently don't know how to turn on a remote. My bad. All right, so who am I? Why should you listen to me, especially since I've demonstrated I can't operate a remote control? So I'm a little bit of an old nerd. I started doing the computer stuff back in the 70s on the Apple II. In 1998, I picked up Linux while I was working desk side support at Merck, and that actually let me leverage that knowledge into a job as a Linux admin starting in 2004. And then in 2015, I ended up at Red Hat. They're a little Linux software company you may have heard of. And it was through that I met Nate and started hanging out here, and then Nate came to Red Hat, and the rest of it, as they say, is history. I'm a bit of a Lego fan. That has not a whole lot to do with this other than that's also a fun building 3D thing. Now, I was trying to figure this out. As best I can tell, I first started my 3D printing adventure in about 2017, right? And again, I can't prove that for sure, but I know it was before COVID. And it was probably right around when you started at Red Hat. That, even though I've been printing, geez, that's almost a decade, I'm far from an expert. It's definitely at a hobby level, but there's a lot of cool stuff there, and I'm just figuring out 3D printing along with everybody else who's doing it. So let's talk about 3D printing. I like to compare it to the way Linux felt in the late 90s and early 2000s, right? It's in a lot of ways very much still a frontier technology. It's not always the kind of thing that Grandma can just pick up and use. So it is evolving on a very regular basis. A lot of 3D printing is very much based on open source tools and concepts, and there's a lot of open community around the whole hobby. Now, the thing about 3D printing is sometimes 3D printing is honestly a solution in search of a problem. Someone's like, I want to do 3D printing. Well, why do you want to 3D print? Well, other than making some tchotchkes, maybe they don't even have a real reason to do it. But honestly, there's a lot of cool stuff you can do with it, even if you want to dive into it as a hobby. And the other thing that this is sometimes a little bit of a frustration point to me, it's not quite the replicator from Star Trek yet. It's not a situation where it will very quickly generate something fully functional and all that stuff. It generally takes a little while and it's constrained. But we're getting there. It's better than it used to be. All right, so I want to make sure that we've got some common vocabulary before we get real deep into this. So I want to go over the anatomy of a typical 3D printer. This is the model that I own today. This is the second 3D printer I've bought. Yeah, that's two fingers. But it's the first multicolor, which is kind of cool. So it's made by Bamboo Lab. And this unit right here, this is the actual printer itself. And then this little contraption right here is the AMS Lite, and I'm pretty sure AMS is short for Automatic Material System, and if it's not, now it is, right? But this basically gives the printer the capability to print in more than one color on a single print. All right, so the the material that we print with, in this case, it's called PLA, and we'll talk more about that in a little bit, feeds through these plastic tubes into this thing right here. This is essentially the print head, and it has an extruder in it, which pushes hot PLA through it. It heats up rather hot, and then there's a hot end right around here where the material shoots out onto the print bed and hopefully into the form of a model. This here is the print bed, and it is heated so that the material sticks to it. The print bed on the A1 can move backwards and forwards. It can move in two directions, frontwards, backwards. The print head can move back and forth on this bar, and this bar can move up and down. So by the combination of motion here, the extruder can be placed wherever it needs to be placed to, in theory, print something. Now, the A1 actually includes built-in Wi-Fi, and it appears on my LAN as its own device. It essentially has like a web server and all that other crap built into it. It also has a camera mounted on the side of this little piece over here so that you can monitor what's actually going on with the print and see how things are going, which is often fun and sometimes panic-inducing. All right. So those are basically the parts of a 3D printer. So that'll give you some idea of the components we're dealing with. Yeah, what's up?
If you could go back to the picture real quick.
I can go back to the picture. Yes, because this is working now, because it's on.
I've seen allusions to AMS system having, I'm going to call it waste disposal because I refuse to use the colloquial name for it, for multicolor or multi-filament systems. Somebody told me they're incredibly wasteful, like they're constantly taking. Oh, the filament poop?
We're going to talk. We're going to talk about that, and I actually have a real live example that I can show you. And there's ways to mitigate that, because mitigate's a fun word. But that legitimately is a concern that some people have. It is possible to print things and waste a lot of material, but we'll talk a little bit more about that later.
Are you going to talk at all about, so this is a modern printer.
Yeah.
Like the printer you had, the printer I had before that didn't have all these bells and whistles?
I don't have a picture of it, but we'll make some references. My original printer was a monoprice, which was a smaller bed, did not do multi-material, and lacked a lot of the automation that keeps things working well. We will talk about that.
Okay.
But yeah, that's part of the evolution here.
Okay.
All right, now there's a workflow to 3D printing. It can sometimes be as simple as find this thing and make it work. But honestly, there's a lot that goes on behind the scenes of taking something as a concept and making it into something solid sitting in your hand, like how we have these save icons printed out on the table over there, right?
Thank you.
So the typical workflow goes something like this. You either need to design your own model or find one. This is where a lot of 3D printing is based on open source and sharing, because the vast majority of models out there are things people have made and offer up for free. Now, there are people who do make a living selling 3D models, but for the most part, I've never had a problem finding a free version of something I've wanted to print. And again, there's ways to design your own should you wish. And we're going to go over each step in this workflow with some examples, right? But the file format that you're going to hear about when it comes to 3D printing, you'll usually hear about the STL format. And we'll talk about in detail what that really is. Once you've found your model or models, you take those STL models and you import them into something called a slicer. The slicer is a program that lets you basically put models together, or a single model, even make multiple copies, and then the slicer will then take that scene and slice it, convert it into what's called G code. Think of the STL as source code. G code is like binary code. every single 3D printer speaks a variant of G code, and the G code actually determines the specific steps that the printer takes when it prints, and not all printers have the same capability. So part of the workflow is taking the generic STL and converting it into the native form that that specific model of printer can print. So that's the G code. Slicing would be analogous, because analogous is a fun word, to compiling source code. Yes, absolutely. Once you've got G code, you send it to the printer. My old monoprice, thank you, Nate, for that call out. My monoprice, I had to use SneakerNet. I would slice the model on my laptop, and I had a little dongle that you could plug a micro SD card into. I would slice the model, copy the model over to the SD card, eject the SD card, plug it into the monoprice, and then a list of the models that were on that SD card would appear on the little LCD panel, and I would scroll down and hit print on the one I wanted. Like that's how I print it starting from day one. The monoprice also had a USB port. What I eventually was able to do, because I didn't have a slicer that I could just do file print on in that day, what I eventually ended up doing was purposing one of my Raspberry Pis and installing a program on it called Octoprint. Octoprint's a web-based print server that you can hook up to printers using USB, and that would actually handle shipping the G code over. So I would slice on that laptop, and then in the web interface, open up Octoprint, upload the model, and then have Octoprint send it over. But Octoprint was really cool because it had live monitoring of what was going on, and I had bought a little camera that I had attached to the monoprice, so I could watch the camera watch it print from Octoprint from my phone upstairs.
Octoprint did a better job with the camera than the Bamboo does. The Bamboo's is very like.
I'm happy with the Bamboo, but yeah. Well, but the thing about Octoprint is because it was a roll your own solution, you could use as a good camera if you wanted to.
Exactly. That's my point. And you can position it where you want it is the thing. That was the difference.
Yeah. But the point is, so you got to get the G code over to the printer. With my printer, the Bamboo, it shoots it using the little electrons over the Wi-Fi network. Again, the printer appears as a device on my network. So that's how I print today. All right, so let's talk about STL files. And I'm going to make this presentation available for folk to download because there's some of it that's like Wikipedia articles and stuff. I don't expect you all to be able to read it. In fact, Jason, if you can read that, I'm really impressed. But STL is stereolithography. It's a file format family, and what it essentially says is, how do I represent the surface of an object as a triangular mesh? So an STL file basically says, we're going to take this object, and when we zoom in and break it down, it could be hundreds to thousands to millions of little triangles, all put together to make a 3D object, right? And again, it's an open file format that's used not only for 3D printing, but for other 3D work. But in the end, it's a bunch of triangles. So where do you get your fresh STLs? Right? Well, one of the most popular open places to get it, the place where I used to get most of my STLs when I started, was the website Thingiverse. Thingiverse is a vendor-neutral website. It's not owned by like Bamboo or any other vendor, and I never ran into an STL there that I had to pay money for. Now, I haven't used Thingiverse in a while, so I don't know if that's changed.
No, they were. I usually just buy it by 19 star.
What's that?
I use Thingiverse all the time.
Yeah, they're a good site, and odds are that unless you're thinking of something really, really, really obscure, some nerd has probably put a file up on Thingiverse that, if not exactly what you need, is really close to what you need. Yeah, dude.
Do not go there without an ad block.
I use Brave, so I've always got an ad blocker.
I had to pull it up on a non-mine computer one, and oh god, it's
But let's say you want to either customize an STL you've downloaded or you want to roll your own. This is a little bit of an eye chart, but this chart basically helps answer the question, what are the tools out there to help me create an object? So if you want to make like accurate parts or things that are not necessarily, like for parametric design, there's a couple of different options. Fusion 360 is one, or OpenSCAD. I'm going to actually show you OpenSCAD because I had a real interesting exercise with it this year at one of our conventions. If you want to do organic shapes, you can do something like Sculpt GL or ZBrush. Not my strength, this type of thing. I'm not an artistic person, so I don't really have a lot of experience with this. One program that I have used for inorganic shapes, things that are a little more simple, I have used Tinkercad. Tinkercad is a web-based 3D design application where you can take existing STLs and add to them or make your own. And then if you want to go cray-cray, if you're more talented, you can advance to Blender. People have probably heard of Blender, right? Open source 3D design stuff. And then for real world copies of stuff, photogrammetry or scanning, things like that, I don't have firsthand experience with third-party apps. Most of the work I've done in this has been web-based hosted stuff through Bamboo, but there are ways to take a photograph or a scan and then make it into a 3D model, which is kind of cool, right? And I'm going to show you a couple of other tools later about how to do some custom STL work, but if you have a design that you need to make yourself, there are many options, and in most cases, there's an open source or free version of the tools you need. So this could be a handy little reference for you. All right, this here is a screenshot of OpenSCAD. OpenSCAD is a scripting, it's essentially a scripting or programming language to describe 3D objects, and then it can export into the STL format. So if you'll bear with me a second, I got to pull some of the toys out of here. But I was charged with making an award for the Capture the Flag event that we had at our company convention called Red Hat 1. And I decided I wanted to make a 3D printed award, but I wanted it to be something I could throw up into a Git repo on general principle. I wanted it to be purely code generated. Now here's the problem. I'm a terrible programmer, right? I'm not good. Like I used to program and was a mediocre programmer years ago, and now I'm just not that great. So what I did, and don't judge me on this, is Red Hat pays for Gemini. I cracked open Gemini and had a conversation with it about, I want to make an award for this Capture the Flag competition, and Gemini and I went back and forth a little bit, and we came up with a concept. And then I said, oh, I kind of like that, make an STL out of it. And Gemini was like, well, I can't generate an STL directly, but I can give you OpenSCAD code, and you can try to, you can put that into OpenSCAD. I'm like, sure, why not? Now, because Gemini is like an eager, stupid intern, we went through a couple of iterations. So take a look at this and then pass it around. This is an early beta of the award. Those black ovals are supposed to be fedoras because Gemini is stupid. So what I ended up doing is, after a couple of iterations, I started with the work Gemini gave me and then went in and figured out, okay, this is how OpenSCAD works, and then I modified by hand. So I guess I'm a vibe coder now. But anyway, so that's the yeah, a vibe modeler. So that's the version where the fedoras were ovals. I'm like, dude, those aren't fedoras, those are ovals. And of course, Gemini was so apologetic about it. Oh, you're right. Those aren't fedoras. Let me help. Ay, ay, ay. Anyway, what I will say is that the badge was a smashing, the winners loved the badges because I put a little hook on it so they could attach it to their lanyards. And it was fun. But so OpenSCAD's a way to do STLs programmatically. All right, slicing. So this is a screenshot of Bamboo Lab, which is the slicer that I use for all my work. And sitting on the bed here is Derpy from the hit movie K-pop Demon Hunters, right? So this is a model, a project essentially, that will print out in 4-color. And that's what it looks like in the preview mode, sitting on the image of the bed. And then when I hit slice plate, the computer does its thing, and we get output that looks kind of like this. And I crop the image a little bit. Yeah, what's up? Derpy is flat on the back, yes. All right. So the slicing result here tells us what is going to be required in terms of filament to print Derpy out. And this kind of goes into some of the stuff we were talking about waste. So there's 4 different filaments, cyan, yellow, white, and magenta. Did I get that right? Yeah, that one's blue is cyan. I can never remember, right? So for this model, it's actually going to use 6.5 grams of cyan, but it's going to purge 4.6 grams of cyan when it does a color change, right? So for the model total, the model itself is 7.2 grams of filament total, but it's going to purge like almost 12 grams. And then the purge tower is another 6 grams, so the total model print is 25 grams. It'll take 2 hours and 45 minutes to print Derpy. Yeah. The purge tower is this little thing over here. When it does a color change, it prints on that to make sure it's cleared out the old color.
So many of those, like.
Yeah. So that makes sure you get a clean print. So anyway, at that point, with a 3D printer, you're dealing with something that you don't always think about in computer land, and that is gravity. You can't print things that float in the middle of the air, right? So this little dog right here, if we were to print this little dog, just the orange parts, his nose would never happen because it would fall onto the plate. So in 3D printing, what we do is we do something called supports. Supports are loosely bonded to the model and provide a way to hold up things that would otherwise fall to the ground because unlike Alphaba, they can't defy gravity. And no, Jason, I'm not singing. That's out of my range. Yeah.
That's what my second question was. Like,
Yeah, go ahead.
so, the cable here. The other.
Don't trip. Yeah.
Wake up point on it.
Yeah.
So here, these are obvious, and I've dealt with them before. They snap right off.
They're tray, yeah.
Right. Down here, you've got tiny little supports for the small curvature. Well, if Derpy was curved on the back, you would get those tiny little supports on the curve. How do you deal with those? Because those are nearly impossible. You don't have any leverage like you do on the tree. How do you break them off?
So, yeah, so some supports are small or the trees are actually a newer style of support. The supports when I first started printing were a lot more obnoxious, and sometimes you would actually break parts of the model removing the supports. Sometimes you have to remove the supports very carefully or with needle nose pliers or other techniques like that. But the concept is the supports are loosely attached in an ideal world and snap cleanly off. Depending on how picky you are, you still might do some light sanding. The other idea is you want the supports to be in areas of the model that you might not be looking at.
The bottom of your print will usually have like lines on it too.
Yeah.
And because the supports aren't perfect, you end up with like filament lines on the bottom.
Yeah, little swirly things. I've got a bunch of prints you guys will be able to see, and you'll probably see that on the bottom. Yes, sir?
So are the supports
Yes. Well, hopefully the model can hold itself up. If you're a no-talent ass clown that made a bad model, there's no promise. Also, the supports are programmatically generated by the slicer. They're not part of the STL design. And sometimes what you do is you can put the model, you can rotate the model to try and get it placed so that it makes the most sense. Sometimes standing up isn't always the best way to print it. Yeah, Nate?
If you're doing super high quality prints, like especially when you get into the resin printing world, a lot of times you're dealing with models that are made by artists, and those artists will build the model in a way that the supports are included because
Okay.
they know where the next place is to place the support.
I've never seen a model come with built-in supports, but I also don't do resin. Nate does resin printing, which I'm going to give him the opportunity to chat a little bit about that later. Jason, are you stretching or you got a question?
Will the bamboo print the dissolvable supports?
Will it print the what's now?
Dissolvable.
It would depend on the material.
Yeah, there's material you can get that built your supports. You just drop the thing into a bucket of water and dissolve it.
That would be kind of cool. And if the supports were from one of the filament rolls, and that's compatible with the bamboo, it absolutely would. I've never looked into that because it's never bothered me that much because I went through bad support hell on the mono price. So the bamboo's just been a pleasure for me.
Who does great job on support?
Yeah. I sound like a little bit of a bamboo whore, and if I'm honest, I am. I love the printer.
Also a bamboo whore. I have the same machine he has, even though it's broken right now because I fucked something up. Like it is a game changer. I started out very briefly with like an Ender ripoff that Eric gave me, so I had a little bit of experience with having to tweak all the levels and this, that, and fucking Octoprint stuff. And once you go from that to an A1, holy shit, it's amazing.
And the other thing that no one's mentioned yet, A1 is the bottom of the line printer from Bamboo.
Yeah, it was like
Yeah.
$300.
They have like upper ends that you can print freaking car parts on. They're crazy.
It does get a little crazy. So
Is also a decent one that I'm familiar with.
we're going to go past 8, but we probably don't care.
That's fine.
Okay, cool. Just want to be consensus. And those of you on the video, thank you. I hope you're enjoying this. All right, so this is what raw G code looks like. It's a text file, and if you look, you'll see things like layers and movement commands and other settings and stuff like that. G code is literally thousands and thousands and thousands and thousands of text commands. There's virtually never any good reason for an end user to mess with it, but it's just kind of cool, right? It's like very rarely do you need to actually look at the assembler, but it's cool knowing you can. Maybe for a CTF, we could do something with G code. Here's a little more G code, which actually has specific, like you can see X, Y, and Z coordinates where it's sending the extruder. Go from here to go to here, here, and then extrude. Go here and extrude this much, right? And then it's got comments it writes in, we're doing a wipe start, a wipe end if we need, stuff like that. And G code can control everything, the movement, the extrusion, the temperatures. It's really the language of the printer. Yeah.
This is actually relevant to something I said somewhere elsewhere I won't name, but could you sabotage a G code and how to put this? Sort of like an anti-pirate threat. Sabotage a G code to just suddenly start spewing crap halfway through.
So Bamboo lets you have profiles for your print devices. And I've got a print profile for my A1 that's got custom G code that it injects into every print that makes it extrude less when it does a color change to try and save on filament. You could potentially inject malicious G code if you got your hands on someone's slicer and inserted your own G code, but at that point, yeah, you've got physical control over the computer. You could do a lot of stuff.
Well, you could do the opposite though. You could have G code that you like put on Hindenburg to show off what I made, and a less
Yeah, but most people, when they're downloading stuff to print, they're not downloading the G code, they're downloading the STLs, and then the slicer compiles it into the G code for your specific printer. So it would be far more difficult to sabotage an STL because remember, an STL is just a bunch of triangles.
Now, G-code can do stuff like tell the hot end to overheat, right?
Yeah, oh yeah, oh yeah.
That's why you got to be careful with where you're getting G-code from.
Yeah, yeah. If you use custom G code, you should look at it.
Yeah.
And if you're using custom G code, it's normally a short enough snippet, and you should know what you're doing. That it's not going to be a problem. All right, so it's a printer. It uses ink. The 3D ink that I use primarily is PLA, but PLA is just one type of material in the whole sea of 3D printing. Our friend Nate back there uses resin. He's got a resin printer, which lets you do far more levels of detail, but it can also kill you. It's a whole different talk. And then, but the bamboo can not only do PLA, it can do like flexible stuff, so you could like be a horrible person and print out a crock, and it would be flexible, right? Things like that.
You can get,
They have glow-in-the-dark PLA,
I don't know what the
for instance.
type is, but you can get stuff that you can print. I don't know if they'll do it in the A1, but maybe in the higher end one. But you can print stuff that is actually acceptable to throw like in the engine bay of your car. So like you can make a custom intake or something, right? And
Yeah.
it'll resist the heat. PLA won't, because PLA has a lower
There are
temperature.
there are printers you can print carbon fibers.
Right, carbon fiber, that's another one, yeah.
But what is PLA? Well, it's polylactic acid. It's essentially a bioplastic. My understanding is in most cases PLA is made from corn. So it's technically edible. It also, for a plastic, it has a very short biodegrade life. Under proper composting conditions, it'll completely decompose in 30 years, which again, for a plastic is pretty good at 60 degrees centigrade, right? Which is, so it's industrial level whatever the word is. Anyway, it biodegrades better than regular plastic. You can eat it, but you probably shouldn't. So this little video here shows you the start of a typical print on my printer because I wanted you to kind of see what goes on. So the extruder lays down, that's just to clear the head, and then it starts the first layer of the print. Right here, it's printing the bottom of the purge tower because this is going to be a multicolor lizard. So between every layer, it moves over to this purge tower and just clears the head out to make sure it's properly on the next color. And then once it builds the purge tower, it's going to head over and start printing the model out. Don't worry, this is only about a minute or so. But I don't know about you guys, I kind of find watching the printing a little bit mesmerizing. And it also makes a very satisfying sound that you can't hear right now.
You can also see that cover. There's this Bamboo Lab. You can 3D print your own custom cover. Mine's the Terminator face, so like that's even cooler when you can watch it go back and forth.
But you can see now it's laying down the back feet of the lizard, and then the video is eventually going to stop.
You can also tell the slicer, I've seen people do this, I haven't tried it myself, but you can tell it not to print purge tower and instead purge while it's printing infill.
Yeah.
Something that Marc hasn't really talked about yet, but the inside of your print has to be filled with something. Instead of being solid, they do like this crosswork of material. You can have it purge while it's doing infill.
So I know this guy is in green, he's purple. But this is the model that we saw start to print.
Show it to the camera.
So, hi, it looks a little like Pascal from Tangled, right? It's not, but he's kind of cute. This bag is the poop and the purge tower from the green version of this model, from the print. So I'm going to pass both of these around. See, there's the poop, and the purge tower's in there too. So this is essentially the waste from the print.
Oh, he's articulate. Right?
And he does articulate.
Another thing I've seen but haven't tried yet is some 3D printer companies sell a device where you can take that purged material and put it into like a melting pot and it'll make filament out of it.
Yeah, the question is the money you're spending on electricity less waste than the PLA itself? So listen, if you're going to do some people hate waste whatsoever, so they refuse to do multicolor. I'm not that much of a purist, right? But it's inevitable you're going to get some waste if you're going to do multicolor. Now here's the thing. The poop is a static amount of waste based on total color changes, which is determined purely by the number of layers on the print. So what that means is that if you're printing something and you know that you want more than one, the fix for the waste is to print more than one. And I'm going to try to demo this with my slicer. So, and this picture here has its own horror story behind it, which I'm not going to go into at the moment. But that's a terrible AI picture. I'll admit it. All right. Oh, good. I got a mouse. Come on, where's my mouse? Ay, ay, ay.
Everybody say hi, Gia. Gia, you're new, right?
Yes.
Okay. Everybody say hi, Gia. Say thank you, Gia. Don't forget to tip Gia.
Hopefully you're enjoying the presentation on 3D printing, Gia.
Oh, that's cool.
All right. So here is our friend. We've already looked at our friend here, right? Derpy. So we're going to hit slice. We're going to go over to preview. And now it's slicing. And it might be a little hard to see, but yeah, the total amount purged is 11.93. So remember that, 11.93. Now what we're going to do is we're going to go back over. Now it's K-pop Demon Hunters, right? So that means that you're going to have a lot of people who want derpy. God, I'm having a hard time seeing this pointer. Don't get old. So here's what we're going to do. We're going to take derpy and we're going to say fill bed with copies. Doink. So that's a whole bunch of derpies.
That's a lot easier than what I was doing. Fucking Control-C, Control-V to do that.
Yeah, well, I'm lazy. So if there's a...
I'm stupid.
So we're going to slice it again. And let's take a look at what we got. And it's going to take a little bit because there's a lot of derpies. What was our waste? Okay, so now the total usage of filament for the models is 222 grams. You want to know how much is purged on this print? What the heck is the print? Oh, want to know how much is purged on this print? 11.6. So this is actually purging, you're wasting a little less on this print. So for many more models, you've got about the same amount of waste for the print. Yeah.
I'm asking my question, Nathan. I have the speaking rum and coke.
How do I get the speaking rum and coke?
Oh my God, you bitch. I've had problems where I did the whole copy paste thing and multiple ones, and then it's just spaghetti after a while. Does something special have to be set that it knows that you're making multiples, and please don't fuck this up?
What I always do is I would never actually do what I just did.
Okay.
I always put
Everything you just talked about, don't fucking do that.
well, no, just the whole fill the bed. I did that because it was easy and dramatic. Yeah, now when things go wrong. But what I do is I always make sure I've got some space in between my models.
Yeah, okay.
Right? I don't like things too tight and close together. But now let's talk about when things go wrong. Because what you were implying there is maybe some things sometimes go wrong, right? Because we're dealing with stuff in the physical world. Yeah, Nate?
Just one quick comment before you move on. The printing a whole bunch of the same model versus printing the same model several times in a row, it'll go a lot faster when you print a bunch on a plate. Because not only do you save on the amount that you purge, but the amount of time it takes to purge.
Yeah.
Like, if you've got a little tiny seconds to get through a layer, and it takes it 7 seconds to purge.
Ogres have layers.
Right? Like you're spending 7 seconds per 10-second layer. Whereas if you have a whole bunch of models that maybe take 20 seconds to print, you're spending the same 7 seconds to purge, right? So
Yeah. Yeah, it really what it comes down to is that if you're doing multicolor and there's a good reason to do multiple copies, do multiple copies.
Like these little DEFCON keychain badges that I stole from Nate that I made on my printer.
yeah.
All right, so
Made in Fusion 360.
you have many foes when you are printing in 3 dimensions. The first thing you're fighting, believe it or not, is humidity. PLA is a funny beast. When PLA absorbs water, it becomes brittle. And brittle isn't good. Brittle can break. I'm actually wanted to pass this around. This is a spool of black PLA, and it's intentionally almost used because I wanted you to be able to see the little ditty here that lets the printer read what color it is. But feel free to take a look at that. That's black PLA on the spool. But when PLA absorbs moisture from humidity, it gets brittle and can snap. And if it snaps, then the print can fail, right? All of a sudden, it snaps in the tube, and the printer goes to print, and there's no PLA in the extruder any longer, and the printer's like, help me, help me. And depending on your printer, it can be difficult to recover from a failure. The Bamboo's pretty good. The Monoprice, when the Monoprice went bad, when a print would fail, it was over. I never ever got the Monoprice to successfully resume a print, even for something silly like a broken PLA or PLA running out.
The other, I was just going to say, the other cool thing about, and I don't know if other printers do this spool, you see how it's on this plastic reel? Most PLA comes on like a cardboard or plastic reel that you then throw away when you're done. Or if you're like me, you wrap your Christmas lights around them because you don't know what else to do with them. These are designed, I'm not going to open it because I don't want to make a mess. These come apart and you can buy just a refill.
In fact,
Spool, which is pretty cool.
Yeah, I know. That's the only way I buy PLAs now is in refill form. You can also print those spools. If you run out of spools, you can basically, the machine can replicate itself.
Whenever I pick a new color, I buy a new spool. And
All right. So humidity leads to brittle PLA, which can lead to PLA breaking, which is bad. One of the most common problems you can have is poor bed adhesion. So the print bed, what you need to do, there are certain defaults when you print. And what I found is that the default temperature of 60 degrees centigrade isn't quite enough for me. So I have the default bed temperature be 65. The hotter the bed, usually the better the PLA will adhere to it. And the problem is, if you have poor bed adhesion, a 3D print is basically layers laid on top of each other. So if it prints a layer and then it goes to print a layer on top of it and the layer below is not solidly adhered to the bed and it starts to slide, that's not good. That print is probably going to fail. Yeah?
Basically, High Valley, pretty much every time we do a job, we run over the plate for root temperature.
Right. So the other thing is, people touch things. You as the printer owner touch things. The oils on your fingers will make PLA not stick to the print bed sometimes. So one should periodically clean the print bed with like isopropyl alcohol and make sure there's not crap on it, and that'll help with bed adhesion. Poor bed alignment. The Bamboo has a process that it runs. It takes about 20 minutes when you first set it up in a new location, which calibrates everything. So if I move that printer to another room, I just have it run that calibration again to make sure that everything is level. Also, it runs a bed leveling routine as part of every print, which doesn't take very long, but what it does, it basically makes sure that it's printing as flat as possible. because if the bed isn't level, suddenly you've got gravity pulling the PLA to one side, which is fighting the adhesion, and if the adhesion loses, the model starts popping off the print bed, and then you're done. Right to jail. Stupid mechanical failures. I think I have a picture of that. This was a stupid mechanical failure. I'm printing this lizard the other day, and all of a sudden my watch goes off because my watch is slave to my phone. My watch is an edge device for my phone, and my phone runs Bamboo Handy. Well, Bamboo Handy monitors my print queue, and it's like, the print has stopped. There's a problem. So I go to my computer, and I've got this warning, unable to feed filament into the extruder. This could be due to a tangled filament or a stuck spool. If not, please check if the AMS light PT FE tube is connected. And the printer had stopped, right? And this is the camera showing the print job. This is a screenshot from my Bazite machine. So, and I saw this suspicious piece of green filament up here. I'm like, that's not supposed to be there. And I was on a one-on-one with one of the guys who works for me, and I'm like, Dave, my printer failed, and I gotta know what made it happen. And he's like, well, we're done, we're good, you can go. So I ran into the other room and saw this. So what had happened, this gray tube right here is supposed to be in this little black receptacle right here. What had happened is when it pulled the PLA back to do a color change at one point, it must have popped the tube out because it's mechanical, friction. And when it went to feed the green, it was pushing the green and pushing the green and pushing the green into the air. Yeah, Nate?
I had a similar failure to this on my ender. The ender was not smart enough to know.
Yeah.
And it did not have all the sensors that the Bamboo does.
And
The same thing happened where the tube, the filament tube popped off. I came down in the morning to a absolute, like,
mess.
mess.
Yeah. We'll talk about that.
It was just like all over my print.
Now there's the model right there. And you can see the models printed, quite a bit of the models printed. Were this my mono price, that model would be garbage. Right? Zooming in, oops. But so it was actually very simple. I rolled the spool back to pull this PLA back into the gray tube, took out my multi-tool, cut a nice clean cut at the end of it, made a nice clean cut at the end of it, and then fed the PLA into the extrusion head, and then clipped the tube back in. Punched the continue button on the front of the Bamboo, big bam boom. An hour and a half later, the green lizard was done. It recovered gracefully. Woot, 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 happy ending.
Have you ever been able to, I'm sorry if I keep stopping your thoughts.
No, it's a good discussion.
Have you ever been able to recover a print? So for those who don't know, on the A1 you can see it gives like how many levels have been printed, like X out of 100,000 or whatever it is. Have you ever been able to recover a print by level, or if the print?
I've never had to.
The print eventually, okay, because I've had prints fail spaghettiing, but it was good up to a point. That fucking shit. But it was good up to a point, and I was trying to see if I could determine at what completion level it did, and see if I could go back and do it that way. Claude was like, that's a pipe dream.
Yeah. So spaghetti is the nightmare scenario for most 3D print hobbyists.
I love that you come with problems.
Yeah. So this bag right here are the casualties of minor spaghettiing. But a spaghetti refers to the loose PLA that's like spewed all over right here. Generally, you don't want it to look like that. This is an extreme example of spaghetti. But usually what happens is there's some sort of undetectable failure. The printer doesn't realize there's a problem. And we've tried using AI and cameras to detect spaghetti visually, and it generally never works, right? But what happens is the print head is no longer making contact with the model, but continues to fire PLA into thin air like an idiot. And then that's where the spaghetti comes from. So this bag shows various models, some that have like little strands of PLA coming off of them, and some that are just sad pieces of things that were all minor failures and spaghettied out. I'm giving you cardio. Yeah, well, you know, because we care about you and we want to make sure your heart stays healthy. You can take the stuff out. You can take those out of the bag if you want, the spaghetti failures. But those are generally, yeah, this print, or at least this piece of a print, is shot. The best way to avoid spaghetti is to use known good PLA. Sometimes with PLA, you get what you pay for. These, the black ones, I printed 2 trays of these little worms for tonight. You're going to get some parting gifts. One of them was magenta PLA actual from Bamboo, and the black ones are over something that my son-in-law uses and swears is good PLA. Overture. But I had a bunch of failures on the black. But the Bamboo brand won. There is a success. I think it had a little bit of spaghetti on it, unless I missed it. But it's not supposed to have support. That's an actual failure. Those don't print with support. Anyway, so the best way to prevent spaghetti is by having a clean print bed, using known good PLA, and hopefully a system that can recover gracefully. Spaghetti on the monoprice was very, very common. Okay, so let's talk about some stuff that goes a little beyond just printing out a couple of things, because I've got a couple of really crazy cool things I like to do. One of the things that I discovered was this technique called U-Forge. And I actually have 2 U-Forge prints that I brought in. The Star Wars one was done by somebody else, and I just downloaded the project. But this picture here, this is my grandfather. This is from a picture that's probably 70 years old now, and I scanned it in and made a U-Forge out of it. And what you'll notice is when you look at these, there's a 3D aspect to them. U-Forge works on the idea that filaments, based on their color, let a certain amount of light through, right? And so what you do is you have a model where you have darker PLA on the bottom and lighter PLA at the top, and then it color changes at specific layers, and then you end up with the U-Forge style printout. So what I'm going to do, and this might be dangerous because, again, my resolution's a little wonky, and I'm trying to use a mouse. Let's see. No, that's caps lock, not tab. Dang it! All right. And that, I also don't have a mouse pad, so that's fun. Here we go. All right. So let's see. We want documents. We want 3D print prezo. We want U-Forge. We want to launch the app image. Yeah, this is all Linux. All right. So this right here, oh my God, I'm so out of focus. All right, so this is the U-Forge app, and what we've got now is it's assuming I've got a couple of different monochromatic things loaded. So what I want to do is I want to change colors here a little bit. Oh, I forget how to do this, because it's been a little bit. All right, here's what we're going to do. We're going to open up an image. Geez, I can't friggin' read.
Hey, Mark, not to rush you, but I kind of gotta be out here at 8:30.
All right. All right, you know what? Yeah, this'll have to wait. But what essentially, with UForge, you load in an image and then you adjust the sliders to determine the color balance. And then once you're ready, it produces an STL file. And then, alongside of that STL file, it produces a description. Oh, you know what? We can do it this way. This'll work. I promise it'll work. A little bit. Here we go. Assuming I can click. Let's see, projects. All right, here's the let's see if this works. No, that's not it. All right, so this is the description file after I prepared a UForge project, and it might be hard to see, but what this does is this gives you the settings in the slicer, and the part that you probably can't see at all is right down here where it says swap instructions. Start with black. At layer 8, switch to gray. At layer 13, switch to this other gray. And at layer 29, switch to white for the rest of the print. So once you've got the STL generated, you then go into the slicer and you can say on the sides of the slicer, switch to a different color at this point, and that's how it does the UForge. And it's really kind of neat.
One quick last question.
Yeah.
Could you save it to the end? Sorry, I'm on a clock today.
The other really cool thing I like to do are lithophanes. Lithophane says you can make anything, you guys, some of you probably knew this already, out of the 3 colors, cyan, yellow, and magenta. You don't even need black. And so what you can do is you can take a picture and load it into the web interface, and it will generate the STL to print a lithophane. It looks white on one side, and on the other you can see there's colors, but then you put it in a frame that's got an LED backlight board on it. Now this might get pissed at me, but I'm going to do this anyway, because my dock will now not have power. And then, when it's plugged in, it's a picture, which looks kind of cool. I'm going to leave that up here. Oh, and it's upside down. But I have a new little family tradition. When the family and I go to Disney, I take one of the pictures from our vacation and I make a lithophane out of it. So I've got a pile of little lithophane images from our Disney vacations. And again, to do that, Bamboo has a website called Maker Lab. That's the web-based control that lets you generate the STL for the image in the frame. And the only thing extra you need to buy is the LED board, which is actually kind of cheap. And in fact, Maker Lab is their experimental site for all sorts of groovy projects. Some of them are really cutting edge and some of them are pretty well tested, but it's some cool stuff you can do using Bamboo to do, well, really cool projects. Flexi things. I thought Josh was going to be my buddy here, but these are one of my favorite things. These are print in place models that move. So we've got them in magenta, or is the pink magenta? We got them in magenta and black, like Good and Plenty's. But for whatever reason, and maybe I'm just a young child at heart, I like the flexi print things which print in place, but somehow they magically move. I know it's just physics, but it feels like magic.
I printed a little sheet of like, it was, I guess the best way you could describe it is chainmail. And it was the coolest thing, because you could pick it up and like lay over your arm, and it was just like chainmail. It was awesome.
It is cool. So how do you get started with all this? Well, honestly, I've talked about it a lot, and I'll admit it. I'm not getting paid to pimp Bamboo, but I'm a very satisfied Bamboo customer. They make a very friendly out-of-the-box experience. You don't even need to use a desktop. My daughter and son-in-law run their Bamboo mostly through their cell phones, right? I know Lucas knows how to use the slicer, but Maggie just downloads stuff using Bamboo Handy and prints right from her phone, and they use the heck out of it. Now, I understand Bamboo Labs, that they're not perfect like any company. To get the full Bamboo experience, you do need to use their cloud, and that aspect is a software as a service, and it's also not completely open. If you love their hardware, nothing's stopping you from hooking it up and not using their software as a service aspect of it. And if that's still not good enough, there are many, many options. You can spend a little bit of money, you can spend a giant pile of money, and there's still a very hobbyist range of printers where they can even print themselves. Like, you own a 3D printer and it can print most of the parts to make a copy of itself, other than the electronics and some of the metal stuff, right? So that rabbit hole gets real deep.
The other thing is, yes, Bamboo makes you use their cloud, but to my knowledge, there's never a charge for that.
No, it's just some people
Service that goes with it.
Some people are not comfortable using anything cloud-based because what if it goes away, which is valid, and what about privacy, which is also valid, and some people are on the Richard Stallman end of I want everything to be totally free and open, which again, valid. Sometimes in your life, as Phil Leotardo mentioned, you got to compromise. He spent 20 years in the can, he wanted manigot, he compromised. He had grilled cheese off the radiator, right? So I like my 3D printing experience to be very easy. So for me, Bamboo is worth it. That was a lot. Unfortunately, those of you online can't ask questions, but is there anybody in the room who has any questions? Because we did go a little long, and you do need to get rolling, but we got a little bit of time. Was that cool? Oh.
Sorry, what's the minimum amount of time it takes you to print something to the most amount of time?
Most models, the smaller stuff can be done sometimes in 10 or 15 minutes. The longer prints can range hours and hours and hours. My personal rule of thumb, I don't like to print anything where I need to be asleep. I haven't had to break that rule, but like if it's 5 o'clock at night and I've got a model that's going to take 12 hours to print, I work remotely, so I work right out of my home office. I'll just wait and print it in the morning so that I can monitor the situation. If I need to address a failure, I can do it immediately.
The longest print I did was 46 hours.
I've had some long ones.
Yeah.
Yeah. Thus, leading to that one where I woke up to a spool of filament all over my maker room.
Can you save it too? If you catch it in time, can you save
Yes.
the product, or do you have to always restart?
So the mono price, you were dead. My old printer, you were dead. The Bamboo, I have been able to recover from 90% of the failures I've had.
Bamboo is very good about it. If it can detect the failure before it moves to the next layer or something, because that's what ruins you. If you
Yeah.
get to the next layer or you're partway through a layer and it doesn't know where it died, then it's impossible to pick up because you'd have to figure out exactly what dot it was about to print, right? But yeah, the Bamboo's very good at detecting it.
Yeah. Anything else? All right. Thanks for having me. I enjoyed it. I like talking about nerd stuff. Woof.